In this video, we will do some more applications that just deal with linear models in general. So really what we're trying to do is we're trying to read a massive story problem like this and be able to turn it into a linear equation, not using the distance formula, not using the interest formula, etc., to just take what they give us in the information and create a model from it. So in this case, we have a bank that charges a monthly fee of $2 plus an additional charge of 5 cents for each ATM transaction. So whenever we see the word each or per, we need to pay attention because we might have to end up multiplying. We're considering moving our account to another bank that charges no set monthly fee, but does charge 20 cents per ATM transaction. So way more per transaction, but no monthly fee. So we're going to write a linear model representing your cost each month. So each month cost is C of X for X ATM transactions at each bank. So let's start with Bank A. Notice we're going to use the same variables for each. So I have a lot of students who try to use A for one variable or one bank and B for the other bank. Don't do that. We're just going to label them as Bank A and Bank B. So for Bank A, my cost would be the $2 plus 5 cents for each ATM transaction, and that is X ATM transaction, so 0.05X. Of course, I'm going to turn that into 0.05 and not 5 because that would mean $5. For Bank B, my cost is no set monthly fee, but 20 cents per ATM transaction, so just 0.2X. Write a linear model representing your cost for each one, which we did. Then use the model to determine the cost of each bank for 18 ATM transactions. So basically we're trying to decide, should we switch to a new bank, which means I'm going to now find C of 18 for each of my banks to determine if it's a good idea for me to switch. So for the first, I have 2 plus 0.05 times 18, which would be 2 plus 90 cents, or $2.90. That's my monthly cost for Bank A. For Bank B, it's 0.2 times 18, which would be 3.6 or $3.60. So would it make sense for me to switch to the new bank? No, because my second bank cost me $3.60, which is more than my first bank of $2.90. Here's a question for you to try on your own. So press pause, try this question, then press play to check your work. So here you're having a yard sale and you're trying to purchase some signs, and Fast Signs charges you $1.20 per sign. Sign Me Up charges $1.10 per sign plus a one-time setup fee of $15.90, which seems a little steep. Write a model representing cost for each, and then determine the number of signs for which the cost from each company is the same. So let's start with Fast Signs. My cost is simply $1.20 per sign, and X represents signs. For Sign Me Up, I've got C of X equals my $15.90 plus $1.10 per sign. So now I need to determine for which cost what number of signs the cost is the same. So it would make sense that the cost would equal the cost. So 1.2x would equal 1590 plus 1.1x. This is how I would solve to find when they are equal. So I'll subtract that 1.1x from each side, which gives me 0.1x equals 1590. And then, of course, I would divide each side by 0.1, which is really the same as multiplying it by 10, which gives me x equals 159. So the question says, what number of signs would the cost be the same? So if I were having 159 signs, the cost for each would be the same. So I don't know about your yard sales, but for me, I would tend to stick with Fast Signs because I don't think I'm probably going to print 159 signs.